Okay, class. Yesterday we talked about zero error. What is zero error? Zero error means that when we have instruments like this one, we mentioned before, this is a electronic balance, right? So there's nothing on the electronic balance yet, but there is a reading here, 0.02 gram. So this reading is actually called the zero error. So the zero error for this electronic balance, it's actually 0.02 gram. Okay, so for such a device, there is an error there already. So how do we correct this? The method is, you will notice that on the electronic balance, there is a tare function. Okay, the tare function, you can press it, then we can reset the electronic balance to 0. All right, so the first error is called zero error, can be reset by pressing the tare function. Then we also talk about parallax error. Remember the 3 A's. Parallax error, it's when the eyes are not in the right place. Okay, so for example, a ruler, you can tell that the ruler is actually measuring the length of a glass rod from left to right here. So what's the right way to read the length of the mirror? The right way is you position the eye so that the line of sight is perpendicular to the marking on the ruler. Okay, so your line of sight must be perpendicular to the marking on the ruler. So for measuring cylinder, the one showing here, the liquid is actually inside the measuring cylinder. So how do we read the volume accurately? We actually should position our eyes such that the line of sight is level with the bottom of the meniscus. Okay, so you can see the surface a little bit curved. You read to the bottom of the meniscus, then you read the correct volume. All right, so in this case, I think the volume is 50 cm cube. All right, so this is about parallax error. How can we prevent parallax error from occurring? Okay, then move on to the next page. So when we use other instruments, for example, spring balance, this instrument is to measure forces. Okay, we will learn all this in the future, but for now, just remember this is an instrument to measure force. Jot it down. So you can see there's a pointer here. How do we read the reading of a spring balance? So similarly, your line of sight, okay, must be perpendicular to the marking on the scale. So what should the reading be? If you take a look, the reading should be it's between 2.0 and 2.1. So it's 2.05. So the reading is 2.05. What's the unit? Newton. Okay. Then the next one is a thermometer. This is the old-fashioned thermometer, not the one you measure in the morning. Okay. We position the eye so that the line of sight is level with the top of the meniscus. So for the thermometer, the liquid surface is actually curving upwards. Okay. So when you read it carefully, if you look at your notes carefully, the reading should be 38.2 degrees Celsius. Okay. So make sure your line of sight, okay, is level with the top of the meniscus. Okay. All right, we move on to the next part. What is precision? Precision, to some people, they thought precision is the same as accuracy, which is not true. Okay. Precision means that if we take multiple readings, the readings are very close to one another or even the same, then the measurements are precise. I will give you examples very shortly. So when multiple readings are taken, they are represented by multiple black dots. So So the diagram here shows you 4 charts. The first one, you can see the black dots are very close to each other, right? They are very close to one another. So I say that the readings are very precise. Similarly, for the second one, look at the black dots. They are very close to each other. So again, we say the precision is very high. Okay, then look at the third and fourth diagram. The dots are everywhere, very far away. So low precision. Low precision. Get it? And then all right. So learning points, okay? So complete the sentence below. Something is a proposed explanation for an observation that can be tested scientifically. So make a guess, what's the answer? A hypothesis, okay? The word of a measurement refers to how close a reading is to the true value of the quantity. The word is the accuracy of a measurement. The word of repeated measurements refer to how close the readings are to one another. If the readings are very close to one another, we say it has high precision, right? So the answer is precision. Okay? What errors are introduced when the eye is positioned wrongly when making measurements? So if the eyes are positioned wrongly, the error is called parallax error. Remember the 3 A's, okay? Parallax errors. If an instrument gives a non-zero reading when the true value should be 0, then it has 0 error. Remember the electronic balance? If there's a 0 error, we can press the tear button to reset, okay? To remove the 0 error. All right. So this part we don't need to learn. So let's move on to next slide. Okay. So developing explanations and solutions. All right. So I hope you continue to copy this in your notes. Okay. So once you finish it, then next week when you come back, we would like to collect your file for file check to see if you have done your home-based learning properly. All right. So you turn to page 15 of your class notes. Okay. So data collected from investigation can be used to identify patterns and trends. By studying these patterns or trends, possible, can you copy the answer in your notes? Possible explanations for observations can be proposed. This in turn develop solutions to problems faced in daily lives. Okay. Data collected can be represented in different ways. For example, observation can be recorded in the form of audio recording. We can take audio recording. We can take videos. We even can take photographs of something we observe. And we can also represent our data in the table format. Okay. And also using graphs. This is a graph. Okay, very visual. It is good practice to record the processes, observations, and findings in an investigation. Okay, record down the processes, especially the observations and findings in an investigation. Findings are very important because that's when you collect your data. Okay, recordings will be useful when scientific findings are presented. Okay. For example, when you do experiments, when you want to present your results, it will be very important to make sure your findings are recorded properly and presented in the correct, the most friendly format for other people to use your data, right? So Scientists use different means to present their findings, and it can be scientific journals for people who will go on and study further. We study a lot of scientific journals in universities. Okay, conference. Yeah, we go to the conference to listen to the experts, to share what they have discovered. And scientific book, if you have a lot of articles there, they might publish it in the form of a book. And the different forms of communication allow the scientific ideas to be critiqued, meaning you present your idea, other people hear you, will try to ask you questions, and you explain. If you can explain your idea, everybody's convinced, then your new idea is being accepted by other people. Okay, so the scientific method basically means this whole flow of sequence. You observe something, then you can ask questions, you can do some research, you come up with a hypothesis, then you can do experiments, collect some data, then in the end you draw your own conclusions. Okay, so the scientific method always started off with observations. We see things, we observe things, then we ask questions. Why is it like that? Okay, then we can come up with a hypothesis, a proposed explanation. Then we do experiments to test our own hypothesis. It could be correct, it could be wrong. Either way is useful. Okay, record down and analyze our results. We can discuss with others, summarize our results, and draw the appropriate conclusions. Communicate your findings with others, because at the end of the day, whatever we find useful, we would like to share with other people, so that people don't have to duplicate the same thing again. Okay, if it's proven, it's accurate, then other people can benefit from our findings, right? Okay, so that's the my recording for the notes, completing the notes. So right now, what we are going to do is, I would like to invite all of you to our workbook. Let me see. Okay, our workbook. Here. Okay, I would like to invite all of you to open your activity book. Downloads. Let me look at my downloads. Okay, I would like to invite all of you to actually open your activity book 1.3.4 to Earth is Human. Okay, so let's take a look at what are we supposed to learn. Follow me. Okay, whatever I highlight, I hope you can try to follow me. Show an understanding that accuracy refers to the closeness of agreement between a measured value and the true value of what's being measured. Okay, and show an understanding that precision of measurement refers to the closeness of agreement between measured values obtained by repeated measurements. Next, zero error. It's when the measuring instrument registers a reading when there should not be any reading at all. Identify parallax error. As an error in reading an instrument as a result of not viewing the measurement scale from the correct position, because the eye is not in the right position. Okay, so errors in measurements can be reduced or avoided altogether. So we're going to answer the questions to learn more about accuracy, precisions, and errors. So questions. John and Jia Li each took 100.0 gram mass. So the mass is actually 100.0 gram. They weighed it using a different electronic balance. The results are shown in table 1.8. So who had more accurate results? Circle the name and explain your answer. Okay, So who had more accurate results? John or Jiali? Take a look. John's results, let's look at John's results. 99.6, 100.1, 99.8, 99.8. It's very close to the 100.0 gram mass. But for Jiali, his results 103.1, 103.1, 103.12. So you can see Jiali's readings are generally higher than the actual reading of 100.0 gram mass. This is the how to call this? So this is the true mass. Okay, this is a true mass, and John and Jiali are simply measuring the mass using different electronic balance. Okay, so what we are going to do is we see who have more accurate results. More accurate results means what? Meaning the results are closer to the true value, 100 grams. So whose values are closer to the 100.0 grams? The answer should be John, right? John's result, it's all very close to 100. So answer should be John. Okay. So the question is, you circle the name. You circle the name. Circle John. All right. So why do you say John? Let's write down the reasoning. We can see that John's readings are very close to. We can say that John's readings are closer to the actual or the true mass of 100.0 grams. John's readings are closer to the actual mass or true mass of 100.0 grams. Okay, who had more precise results? This word precise, meaning precise results, that means the readings are close to one another. Whose readings are very close to one another? Precise. For example, like John's result 99.6, 100.1. What's the difference between these two? You see the difference? Use your calculator to find the difference. It's 0.5 gram, right? These two, what's the difference? 0.3 grams. What's the difference between this one? 0 grams. Look at Jiali's results. What's the difference between his result? 0 gram. The difference is 0.1 gram. Difference is 0.1 grams. So do you feel Jiali's results are actually closer to one another? So we write it down. So the answer should be Jiali's results are more precise. Reason being, Jiali's readings are closer to one another, right? Okay. One of the students realized that his electronic balance gave a reading of 3.0 grams when there was nothing on it. Oh no! The electronic balance gave a reading of 3.0 gram when there was nothing on it at all. Yet the balance gave a reading. So what kind of error is this? Make a guess. What type of error was introduced? Is it parallax error? Is it zero error? Think about it. The answer is zero error. Okay. Do you think the error in question 2A can be corrected? Can we correct that zero error? Yes or no? If so, briefly describe how it can be corrected. If the zero error we learned in the lesson, you just need to press the, remember there's a button called tear. You can press the tear button to reset the electronic balance. So the answer should be yes, it can be corrected, right? How? We say that zero the zero error on the electronic balance, okay, can be corrected by pressing the tear button, okay, button before placing the 100.0 gram mass on the electronic balance. Okay, that means before you measure it, we actually can press the tear button before we place the mass on the electronic balance. Okay, so for question C, we don't need to do it, so we can simply cancel C. Question 3, the last one. Okay, John measured 50 ml of water using a 100 ml measuring cylinder. He read the measuring cylinder from 3 different positions, A, B, C. The eyes are positioned differently. From which position should John take the reading to ensure an accurate measurement? Okay, so which position? So this question is about how the person should do the reading properly to avoid the parallax error. So the answer should be, what's your answer? Is it A? Is it B? Is it C? Remember to avoid the parallax error. Do you remember what we learned in class? Remember, the line of sight must be perpendicular to the scale, right? Must be perpendicular to the scale. So the scale, it's okay. Maybe for the measuring cylinder question, maybe I should emphasize something. If you look at the measuring cylinder carefully, the water surface shouldn't be flat. It's having a small curvature. We call this the meniscus. Okay, meniscus. So how do we read the volume? We need to read it in such a way that we go to the bottom of the meniscus. Okay, then your eye should be there. So you read off the reading from here. So your eye should be level with the bottom of the meniscus. So which one is the right position? A, B, C? The answer is B. Okay, B. B is the answer. Yep. I think that is all for today's, maybe you write down the sentence here. You write something like this. They didn't ask you why, but you just add something a bit more so that you remember what's the reason why we chose B. So we can write down to prevent the parallax error, the line of sight must be level with the bottom of the meniscus, meaning the curved surface of the liquid. The line of sight must be level with the bottom of the meniscus in the measuring cylinder. Okay, that's it. That's the final answer. That's all for today's HBL. Hopefully you have understood the lesson and done all the writing inside your activity book plus your notes. Okay, so hopefully when I collect your file for checking again next week, everybody will be ready to submit for file check. Do a proper job, okay? Thank you, class. That's all for today.